Question 7 on this Practice AP Stats test. This is a pretty good question, one I wouldn't be surprised if you saw something similar to on your test. This deals with z-scores, and since it deals with z-scores, there's really two different ways you can answer it. You can do it totally algebraically, or maybe better with a little bit of understanding. So first, the algebraic method. In order to solve this problem algebraically, you need to know that z is equal to the observation minus the average divided by the standard deviation. I'm assuming that the average and the standard deviation are sample statistics, but in the case that you have population parameters, the formula would look a little bit different, but essentially capture the same information. You take your observation, you subtract the mean, and you divide by the standard deviation. So if we read through this problem, the weight of adult male grizzly bears living in the wild is approximately normally distributed with a mean of 500 pounds. So there's my mean right there. Maybe mu sub m for male is equal to 500 and a standard deviation of 50 pounds. So sigma sub m is equal to 50. The weight of an adult female grizzly bear is also approximately normally distributed with a mean of 300 pounds. So here's the mu for the females. That's 300, and a standard deviation of 40 pounds. So sigma for the female is 40. And what we're asked is approximately what would be the weight of a female grizzly bear. In other words, find x sub f maybe, with the same standardized score as a male grizzly bear. So back over to blue here, that weighs 530 pounds. So what this is telling me is x of the males is equal to 530. If you're the type that just loves algebra, all you do are plug in numbers. Right? My x value for males is 530. From that, I want to subtract my mean for males, which is 500. And then I want to divide by my standard deviation for males, which is 50. Let's see, 530 minus 500 is 30. 30 divided by 50 is 3/5. In other words, 0.6. I want that z-score to be the same as the z-score for a female. So I put an equal sign right here. I don't know the weight of the female. That's what I'm looking to find, x sub f maybe. I do know the mean for the females was 300, and the standard deviation for the females was 40. So I got this equation right here. If I could solve it for x sub f, I'd be done. Pull out a calculator if you want, but I'm just going to do this in my head. To get this all by itself, I'd first multiply both sides of the equation by 40. 0.6 times 40 is the same as 6 times 4, which is 24. That's got to be equal to x sub f minus 300. If I add 300 to both sides of the equation, I get 324 is x sub f. In other words, the weight of the female grizzly bear. The answer to the question is B. Okay, but what if you don't teach math for a living, right? What if you don't love algebra like me? Is there any other way to answer this question? Absolutely. Let's go for a more intuitive approach. All a z-score is a measure of how many standard deviations above or below, if it's negative, the mean an observation is. Keeping this in mind for a z-score is really important. It'll help you not just on this problem, but on other problems. The main purpose of a z-score is to help you compare sets that have different means and standard deviations. Right? If you saw a bear and that bear weighed 400 pounds, would you think it's a big bear or a small bear? Well, it depends. If it were a female grizzly bear, you'd think it's a pretty big bear. Why? Because the mean female grizzly bear only weighs 300 pounds and the bear you saw weighs 400 pounds. But if it was a male grizzly bear, you wouldn't be that impressed because the average male grizzly bear weighs 500 pounds and your little bear only weighs 400. If I want to compare these two different groups, male and female grizzly bears, I need to account for the fact that generally speaking, males weigh more than females. So I saw this bear and it weighs 530 pounds and it's a male. Right? So that's more than the male average. A 530-pound male grizzly weighs 30 pounds more than average. So how much would the corresponding female grizzly bear weigh? Well, you might think that since the average female grizzly bear weighs 300 pounds, a corresponding female grizzly bear would be 330 pounds, right? 30 pounds more than the average. Unfortunately, it's not quite that easy. And the reason why is because the weights of female grizzly bears don't vary as much as the weights of male grizzly bears. So it's not enough to just figure out how much more than average this bear weighs. What you need to figure out is how many standard deviations more than average this bear weighs. So recalling that the standard deviation for males is 50, 30 pounds is a little less than one standard deviation. Instead of thinking about this as 30 pounds more than average, maybe you could think about it as 30/50ths of a standard deviation more than average. Note, you might not leave it as 30/50ths. You might reduce this fraction to 3/5 or even 60% or 0.6, whatever you want. The point is, this bear weighs a little more than half of one standard deviation more than the average male grizzly bear. So how much would the corresponding female weigh? Well, 60% or 3/5 or 0.6 or 30/50ths, whichever you prefer, of the female standard deviation, which recall is 40 pounds, is 0.6 times 40, in other words, 24 pounds. So a female grizzly bear that comparatively weighs as much as this male grizzly bear that you saw would have to weigh 24 pounds more than the female average. 24 more than 300 is the 324 that we came up with before. Oh man, no way I'm going to remember this. My algebra is really bad. I'm going to screw up some calculations. Okay, how about this? This 530, this male grizzly bear, weighs less than one standard deviation more than the mean, 500. How many of these numbers are less than one standard deviation more than the female average of 300? Well, it sure as hell ain't 276, because a 276 pound female bear would weigh less than the female average, so that ain't it. It's not 340 pounds, because 340 pounds would be one full standard deviation above 300. A 340 pound female would correspond with a 550 pound male, but we didn't have a 550 pound male, we had a 530 pound male, so the answer ain't 340. Sure as hell ain't 530. All right, that was the weight of the male grizzly bear that we saw. 530 is a whole bunch of standard deviations, a whole bunch of 40s over our 300. So really, without doing any calculations at all, we've narrowed it down to either B or C. If you're really not going to remember any of this stuff, flip a quarter at this point, you got a 50-50 shot. It was pretty easy to rule out A, D, and E. I guess one more option is if you're really bad with the algebra, but you're good with this formula right here, when you've narrowed it down to two different options, you could just calculate the z-score if x sub f were 324 and if x sub f were 330. In other words, plug in these two answers here and see which one gives you the same z-score that you calculated here in blue.